Good day everyone, my name is Mariel Combis from Group 3 and we will be discussing closed-loop control system. So, there are two ways in which you were able to control a skill, and these are called open-loop control and closed-loop control. But for now, let's focus on closed-loop control system. So, as a performer, you don't actually decide what type of control you use, as it is determined by the type of skill you are carrying out. So, closed-loop control, a type of control that involves the use of feedback and the activity of error detection and correction process to maintain the desired state by individuals to control slow and deliberate movements. The biggest thing to remember when it comes to closed-loop control system is feedback. Feedback is used to compare the desired state and the actual state. Now, kapag may na-detect na error, magre-relation ng signal para magkaroon ng solution or mag-come up ng correction process. So, in human, our body control system is our nervous system. It sends, receive, process nerve impulses throughout the body. Now, nervous system takes input from all the sensors in the body. The sensors send info by the nerve impulse that travel to the brain through the spinal cord. So for us to be able to understand a closed-loop control system better, we have here the four components of control loop system, which is the mechanism needed to achieve our goal. We have comparator, executive, effector, and feedback. So, comparator, the error detection mechanism contains in closed-loop control system, compares feedback of the desired state to feedback of the actual state. Comparator, ito yung nakaka-detect ng error using feedback. Na kapag hindi nag-match or pag hindi na-achieve ng actual state, yung desired state, magsasend siya ng error or magre-relay siya ng signal sa executive. Executive determines the actions to be taken to maintain the desired goal or state. Yung executive, ito yung parang control system. Kasi ito yung nagbibigay ng, ito yung nagpaplano at nagbibigay ng command sa effector. Now, effector carries out the desired action. Effector is responsible for carrying out the plan from the executive. Now, we have feedback. Feedback is the information about the actual state of the system. So, let's take a look at this diagram. This diagram shows the action that must occur in the process of closed-loop control system. We have here the input, executive, effector, output, feedback, and then the comparator. Let's say, for example, thermostat is our comparator. It can sense the difference between the actual room temperature and the desired room temperature. If it detects no error, it takes no action. However, if it detects differences from the actual room temperature, which is lower than the desired temperature, it relays a signal to executive that it is too cold. Now, the executive will relay a message to the effector mechanism that is responsible for carrying out the action. Let's say, for example, na yung effector natin is furnace or yung heater. Ngayon, magta-turn on yung heater and continue lang siya until ma-achieve na yung desired room temperature. So, at that point, if the comparator sends zero error, it relays information to the executive forwarded to effector to turn off. The process continues infinitely as the system attempts to maintain the temperature near the desired state. Now, let's move on to closed-loop control system within a conceptual model. The conceptual model is expanded by adding the control loop system mechanism. So, conceptual model. It is a model of human performance that illustrates how individuals process information in three stages. So, what are the three stages of conceptual model? These are stimulus identification or perception. It detects the environment information. So, sa response selection, which is decision, decides upon the action should be made. Now, in response programming, or actions, it will organize the systems for the response. Next is motor program. It produces command given by the executive. Now, after the motor program command the spinal cord will relay the message to the muscle to carry out the action. So let's take a look at this figure, which is the now the expand conceptual model adding the control closed loop control mechanism. Our input is going to be our stimuli, and under executive nandito yung three stages, which are stimulus identification, response selection, and response programming. Now, under effector, it has several components. Ito yung motor program, spinal cord, and muscle. Now, yung magiging result ng or yung magiging action ng effector, ito yung magiging output natin. Now, let's have an example of closed-loop control system process in human performance. Let's take, for example, a driver. A driver uses his visual information about the position of the car on the road to obtain feedback about the difference between the desired position of the car and its actual state. Now, if such differences occurs, the driver sends them as error. If it is need correction, the comparator will relay a signal to the executive. Now, if the input arrives, magsisimula na yung information process. Magsisimula sa stimulus identification. So, sa stimulus identification, madedetect niya na nasa wrong lane na yung position ng car sa daan. Now, sa response selection, magde-decide siya kung ano ba dapat yung action na gagawin niya, kung kailangan niya bang iikot yung steering wheel pakanan or pakaliwa para maibalik sa desired position. Now, sa response programming, ito yung mag-o-organize kung ano ba yung pagkakasunod-sunod ng mga plans or ng action bago i-relay sa effector. Now, pagdating sa effector, ito yung magke-carried out ng action. Pero bago yun, dadaan muna siya sa several components of effector, which are motor program. Yung motor program yung magbibigay ng command sa spinal cord na magre-relay ng information or ng message or magfo-forward ng message sa muscle para ma-carry out yung action or ma-execute yung movement na kailangan. So, kapag na-execute na yung movement or yung action, ito na yung magiging output. So, in closed-loop control system, we use exterceptive feedback and proprioceptive feedback. Now, exterceptive feedback is sensory information that comes primarily from sources within a person's body. Ngayon, yung exterceptive feedback is the information from the environment and sensed by the receptor for vision. For example, yung driver, ang ginagamit niya is yung kanyang visual or vision to see the position of the car on the road. So, sa proprioceptive naman, so it is the sensory information arising from within a person's body that signals body and limb position and movement, similar to kinesthesis. Ang example nito is yung feel to the steering wheel and the movement of arm and hand of the driver to the steering wheel.
Conceptual model and continuous long duration skills. The closed-loop model depicted in Figure 4.2 is useful for understanding how the nervous system maintains a particular state of human behavior. Yan, sinasabi lang naman dito na yung the closed-loop model na makikita natin sa may Figure 4.2 ay mapapakinabangan natin para mas maintindihan natin kung paano ang nervous system na maintain ang isang particular state of isang motor behavior or human motor behavior. Example na lang nito yung simple act of maintaining posture in stand position. It is a natural behavior that requires form for closed-loop control. Closed-loop control. It is also used for various learned postures, such as one employed by skilled gymnasts when executing a handstand on steel rings. Ayan, yung closed-loop control, sa halos lahat ng postures, pumapasok din dun yan. Ang example na lang nito, yung skilled gymnast, pagka nag-execute siya sa handstand sa isang steel rings. Next. Most movements skills involving the use of various limbs require an accurate, stable posture as platform. Ayan. Without this base, people would unable to perform movements such as throwing and darts and etc. Next. See if you can do it. Models are intended to help us to understand the way a phenomenon might operate. In Figure 4.2, we present a conceptual model of human performance. You can test the usefulness of this model for yourself by attempting to describe how you think of the various components of the model might operate for a person who is attempting to pour a glass of wine. Yan. Ito yung may sinasabi natin na model ng Figure 4.2. Makita natin dito yung input, stimulus identification, response selection, response programming, motor program, spinal cord, muscles, output. Yan, halos lahat sila, umiikot lang sila sa comparator. Next, trackings. A class of tasks in which moving track must be followed, typically by movements of a manual control. Ayan, sinasabi lang naman dito na pag sinabing trackings, meron tayong sinusundan or meron tayong target. Tapos typically, movement siya ng isang manual control o may nagko-control dito. Ayan, next. Continuous tracking skills. It requires the performer to operate a control device in order to follow some continuously varying target. Example nito, driving an automobile. Ayan, paano naging example ng driving an automobile na yan? Where the driver operates the steering wheel of the vehicle in order to properly position on the road. Ayan, di ba nga sabi ko sa may trackings, meron siyang target. Kagaya lang din siya ng continuous tracking skills. Nag-i-operate yung isang driver para maipesto niya ang kanyang sasakyan or para mapuntahan niya yung kanyang pupuntahan. Next, distance runner competing in a 10K race, slow karate movement. These tasks are some dynamic movements to illustrate the importance of closed-loop control during much of person's daily functioning. Ayan, sinasabi lang naman dito na ilan sila sa mga dynamic movements or mga example sila para mas ma-illustrate ang kahalagahan ng closed-loop control dahil isa itong parte ng ating daily routine or daily functioning. Next. Without a doubt, closed-loop models such as shown in Figure 4.2 are the most effective means for understanding how people continuous long-duration skills. Ayan, sinasabi lang naman din dito na ito yung nasa Figure 4.2 na pinakita ko kanina. Isa ito sa pinakamahalaga para mas maintindihan natin yung control continuous at long-duration skills. They are also useful for certain types of performance application. Ayan, kahit sa may mga certain types daw ng performance application, nagagamit natin ito. Ang example nito ay, human factor engineers have used the components of closed-loop models in designing and constructing a variety of electromechanical devices. This non-living robot-like machines are able to mimic some aspects of actual human behavior. Ayan, sinasabi lang naman dito na yung mga human factor engineers ay gumawa sila ng components ng isang closed-loop model para mag-construct at mag-design ng isang electromechanical devices. Ito nga yung sinabi niya kanina na the non-living robot, na kasi isa silang machine, di ba? Tapos, nakakagaya sila ng aspects of actual human behavior. Next. In spite of their potential for application, however, closed-loop control models are not without their limitation. We discuss this in next section.
Good day everyone, I'm Michelle G. Pimol from BPED 2E. Today I will discuss limitation of closed-loop control. Closed-loop control is a system that adjusts itself to varying conditions by feeding output informations back as an output. Ito ay mayroong tatlong level of control. Level 1, control does not use feedback. Explain how rapid movements are performed in sports. Level 2, unlike open loop, it involves feedback. Feedback is termed perceptual trace. Ang halimbawa ko dito ay yung snowboarder. They feel true kinesthetics and proprioception when they're losing balance. They need to act on this issue. They will make quick decisions or adjustment in order to retain a successful outcome. Next is closed loop level 3. Closed loop level 3 is a type of control is very similar to level 2. Except the feedback loop is longer because information on the performances is relayed in the brain. The process also involves conscious thought and attention to external feedback. External feedback is information taken from the environment or concerning performance. Halimbawa dito is yung football player. He need to change the direction while controlling the ball. They will need to consciously thinking about it, and they will need to be taking note of the environment.
Good day everyone, my name is Adrian Carlos Chico from BPED 2E and this is my report. Slaughter-Hamel 1959-60 investigated the length of motor programs for a finger lip gesture. During this experiment, the participants completed 100 practice trials in which they were instructed to stop the sweep hand at 800 milliseconds by lifting their finger off the depressed key for 2 consecutive days. This is Slaughter Abstract. Slaughter-Hamel 1960 devised an experiment using a finger lip gesture to stop a sweep hand to estimate the length of motor programs. He measured the time necessary to inhibit a movement once it was planned and initiated. Replicating the Slaughter-Hamel experiment, we use speech targets outdoors or outdoorsment as the stopping gesture. Participants learned to stop a sweep hand at 800 milliseconds using the voice methods. The participant performed an anticipatory timing task where they were instructed to move in synchrony with the arrival of a moving object. Arrival of moving object at a determined contact point. On 50% of the trials, a stop sign appeared on the screen at it served as a signal for the participant to halt their movements. They performed the anticipatory task under the two difference viewing. The result of the experiment clearly showed that the minimum time required to suppress as anticipatory timing task was prolonged when the participants were forced to use time estimation process to initiate their responses. The longer minimum suppression time for the prediction motion task occluded viewing was the result expected if greater attentional resources had to be deployed to time movement onset during the resources available for responding to the stop signal competing for attentional resources could increase the accuracy of the temporal estimation process. It is likely that a combination of these two effects leads to the longer minimum suppression time.